In this video, we're going to do the first 10 derivatives from black pen to red pen's 100 derivatives video. So the first derivative is ax squared plus bx plus c. So using the power rule, we'll just get 2ax plus b. So the next derivative is, we're supposed to use the quotient rule. So we're going to, the bottom, so the denominator, times the derivative of the numerator, which is cosine x, minus the numerator times the derivative of the denominator. The derivative of 1 plus cosine x is just negative sine x, over the bottom squared. So it would be 1 plus cosine x squared. So this would be, so expanding this out, so it would be cosine x plus cosine squared x plus, so minus minus become plus, sine squared x over 1 plus cosine x squared. So this is pretty nice because this is just 1. So that's 1 plus cosine x over 1 plus cosine x all squared. So this is to the first power, this to the second power, so you end up getting 1 over 1 plus cosine x to the first power. And that is the answer to the second question. The third question, the derivative of 1 plus cosine x over sine x. So it's just the reciprocal of this question. So we're going to just keep the derivative, and then 1 over sine x is just cosecant x, and cosine x over sine x is cotangent x. The derivative of cosecant x, let's think, it's cosecant x, cotangent x with a minus sign, and then the derivative of cotangent x is minus cosecant x squared. And that is the answer to that question. We have the derivative of the square root of 3x plus 1. So we can look at this as the derivative of 3x plus 1, all raised to the 1/2 power. So this would be 1/2 times the outside function minus 1. So 1/2 minus 1 is negative 1/2 times the derivative of the inside, which is 3. So this will be 3/2, 3 over 2, square root of 3x plus 1. So that is the answer to that derivative. Next question. So that we have the derivative of sine x all cubed plus sine of x cubed. So we're going to look at this as u to the cubed. And so when we take the derivative, we'll get 3u, which is sine, and then we have squared x, times the derivative of the inside function, which is cosine x, plus, so now we have to think, so we have to have derivative of sine, which is cosine x cubed, times the derivative of the inside function, which is 3x squared. So this, we can factor out a 3, so we get 3 sine squared x cosine x plus x squared cosine x cubed. So that would be the answer to that derivative. We have the derivative of 1 over x to the 4th. So we're going to think of this as the derivative of x to the minus 4. Use the power rule, so this bring the negative 4 down, x to the minus 5, which would be negative 4 over x to the 5th. Going to the next one, the derivative of 1 plus cotangent x, all raised to the 3rd power. You can think of this as some u function raised to the 3rd power, so we're going to bring the 3 down, so it would be 3u, which is 1 plus cotangent x, 3 minus 1 is 2, times the derivative of cotangent x, which is minus cosecant squared x. So we can just clean it up a little bit, so it would be negative 3 cosecant squared x, 1 plus cotangent x, all squared. So in this one, we have the derivative of x squared times 2x cubed plus 1 to the 10th. So we're going to use the product rule. So we're going to do the first times the derivative of the second, which is 10, times 2x cubed plus 1 to the 9th, times the derivative of the inside, which is 6x squared. And so then we have the second function times the derivative of this first one, so it's 2x. So we're going to factor out a 2x, and a 2x cubed plus 1 to the 9th, leaving us with, so we're going to have 1x, so this would be 60. Instead of 60, it'll be 30. And so this would be x to the 4th, so we have to factor out an x, so it would be x cubed, plus, so we factor out 2x, we have to factor out a 2x cubed plus 1 left. So this would be 2x cubed plus 1 to the 9th, times, so this and this we can combine, so it would be 32x cubed plus 1. And that is the answer to that derivative. Another quotient rule problem. So we have the denominator times the derivative of the numerator, but the derivative of x is just 1, minus the numerator times the derivative of the denominator, which is 2x squared plus 1 to the first power, times the derivative of the inside, with derivative of the inside is 2x, over the denominator squared, so it'd be x squared plus 1 squared squared, so it's to the 4th power. So this will be x squared plus 1 squared minus, so this will be 2 times 2 is 4 times x is 4x squared, x squared plus 1 over x squared plus 1 to the 4th. And you can divide by x squared plus 1, because that's not equal to 0 ever. So this would be x squared plus 1 minus 4x squared to the 0 power times x squared plus 1 to the 0 power over x squared plus 1 cubed. So this would be x squared minus 4x squared is negative 3x squared, so it would be 1 minus 3x squared over x squared plus 1 cubed. And that is the answer to that question. In the last derivative, we have the derivative of 20 over 1 plus 5 e to the minus 2x. So we can rewrite this. So 20 is a constant, so we can write this as 20 times the derivative of the denominator to the first power, negative 1 power. So we have 1 plus 5 e to the negative 2x to the negative 1 power. So we're going to use the power rule and the chain rule. So we get 20 times this derivative, which is, we're bringing this down, minus 1, so it would be minus 1 plus 5 e to the negative 2x to the negative 2 power times the derivative of the inside, which is, so we bring the negative, we do 5 e to the negative 2x times the derivative of the inside, which is negative 2. So let's close all the brackets. So we get, so the negative and negative will cancel, leaving us with 20 times 5 times 2, so that would be 10 times 20, which is 200. This term can go to the denominator, so it would be 1 plus 5 e to the minus 2x squared, and we have e to the minus 2x, which we can bring down to be e to the 2x, and that is the derivative of this. That's the end of the video.